Alright, so we're going to keep talking about section 1.2, which was rational equations. So we did the first half already, and this is going to kind of be in two parts. So rational equations is really meaning pretty much anything with fractions. So anything with fractions. If you remember, hopefully, we did stuff, well, basically our main goal is going to be to get rid of the fractions. Because fractions are nasty and ugly and they make life very, very miserable. So our main goal is to get rid of all the fractions. So this is kind of an aside. If you remember, way back in the day when you were learning to add fractions, we'd do stuff like this. And say, well, what does that equal to? So what you would do is you would say, all right, well, on the bottom here, I'm going to have a 6. I'm going to change the bottom of both of them to 6, the denominator. So that's going to stay the same. But to get from 3 to 6, multiply by 2. So I got 4. 5/6. All right? Remember doing that? So this thing on the bottom, remember what we called that? Denominator. What kind of denominator? Remember? Common denominator? Lowest common denominator? Lowest common denominator, LCD. Okay? Super fun. So we're going to find this lowest common denominator. We've got something, we've got a toddler. Just a sec. Okay, so what we're going to do, essentially, moving forward, is the way that we're going to get rid of all these fractions is we're going to get some equation and we're going to multiply both sides of the equation by the LCD. So that's going to be our strategy. Okay? Yay! Isn't that exciting? Boom, boom, boom. Give ourselves some more paper. Okay. All right. So let's start off with an example. Try this one. We'll start out with x plus 2 all over 4 minus x minus 1 over 3 is equal to 2. Okay? So we want to find the LCD. So we'll take a look. What do we have here on the bottom? We have a 4 and a 3. And here, you'll remember the denominator is 1. So our LCD for this particular equation is going to be 12. Now, if you have a hard time remembering this, think about, well, what if I just had a 4th minus a 3rd? What would my LCD be over here? What would I use? Say, well, that's easy. That makes sense. I would use a 12. Okay, well, it's the same thing here. It can't go wrong. You don't really need that. You can't go wrong if you just multiply everything on the bottom. So call this a last resort. You can multiply everything on the bottom instead of finding the LCD. But honestly, if you do that every time, you're going to end up doing some really just big, giant, ugly math. The nice thing is, you can't guess too big a number. If the number is big enough, it's all going to work out. But if you pick the LCD, that's kind of like the sweet spot. And it makes everything so much better. Sweet spot. Choop, choop. All right, so what I'm going to do is I'm going to get back to my kind of a pretty version of this equation. X minus 1 over 3 equals 2. I'm going to multiply both sides of this equation by 12. All right, so note I use my parentheses. Parentheses are super important here. Now, if this is making sense to you, go ahead and try to work this out on your own. If you want to pause and try to work it out, that's great. If you just want to kind of work ahead while we're talking, that's fine. But you really don't want to just copy this, blatantly. You want to think about why we're doing what we're doing. So I'm going to distribute that 12 across. So a lot of people skip this next step. I'm going to say don't skip this next step. I'm going to say 12 is going to be distributed across the x plus 2 over 4 minus 12 times x minus 1 over 3 equals 12 times 2. Okay? So we had 3 terms here. We had 1 term, 2 terms, 3 terms. So we still got 1, 2, 3 terms, each one of them multiplied by 12. Oops, by 12. Okay? So that's a really, really good way while you're working to make sure that you're doing everything right. So let's take a look at what's going on here. Now, we have a 12 here, and we have a 4 here. So what you want to think about is how can we reduce this? Remember, the whole point of doing this is to get rid of this ugly 4 on the bottom. So let's cross it out. Cross out the 12. If we have 12 over 4, what we have left is a 3. We have a 3 left. So 12 divided by 4 is 3. That's one way to think about it. Another way to think about it is you're just canceling things out. Here we got cancel these out. If I cross out my 12 and my 3, who's left on top? We've got a 4. All right. So now let's rewrite the equation. Now this is also a step that a lot of people skip. Do not skip this step, because this is when bad things happen and things get lost and forgotten. So I'm going to write 3, and who's left here in the center is x plus 2 minus 4, and the guy who's left in the center, x minus 1. And that's going to be equal to 24. Okay? It's very, very tempting to go say, well, I can just distribute this 3 across and I'll know what I'm doing. But no, 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 no. Please don't do that, because you're just going to make mistakes and it's going to be ugly and everyone's going to cry. It's going to be very sad. So go ahead and write both of these steps out very, very carefully to make sure you're doing everything right. All right, so what we've established here, what we've gotten here now, is we had this ugly, ugly equation with fractions and all this kind of stuff, and we turned an equation like that we didn't know how to solve into something that we do. This equation should make you much happier because there's no fractions anymore. And that was the whole point of doing this, to get rid of those fractions. So now what we want to do is distribute the 3 across. We're going to distribute this whole negative 4 across, and we'll be good. So 3 times, whatever that is, x, it's 3x plus 6. Now the negative 4 gets distributed, so I've got negative 4x. Negative 4 times negative 1 is plus 4. Okay, going to combine like terms. Combine like terms. So I've got 3x minus 4x is negative x. 6, kitty. 6 plus 4 is 10. Hi, kitty. And that gives us 24. All right. Now we want to get all the x's on one side and all the numbers on the other side. So we're going to get rid of this 10. To move the 10 over, we're going to subtract 10 on both sides. And now we've got negative 10 equals, what is that, 14? All right, now I need to get rid of that negative sign. So now we can divide. Remember, never divide until you're done plussing and minusing, until you're done adding and subtracting. Now, technically you can, but it's just one of those things that really messes people up. So, like, you know, don't be over here and be like, oh, well, here's this 3. I'm going to divide everything by 3. Don't do that. As long as you've got stuff left to do, like adding and subtracting, just don't worry about dividing until you're done with all that. So you have all the x's on one side and all the numbers on the other. So I want to get rid of this negative here. So I'm going to divide both sides by negative 1. And now I've got x equals negative 14. And there's my answer. All right? Reasonable, strange, creepy. And there we go. So take a look at that. Think about that. We're going to go to the next example. So if you want to pause before then, you can. I'll be right back. So the next thing we want to talk about then is just to do another problem and see how well that's sunk in. All right? So let's try next example. Try 5 plus x minus 2 over 3 equals x plus 3 over 8. Now think about it. Try to work it out. Pause this. Figure something out. If you're completely stuck, go ahead and keep listening. But please just try to pause it and work it out. That way you can tell if you're just thinking and got your brain in gear, if you're just kind of copying arbitrarily. So for our first step, what we want to do is we want to find the LCD. So we look at what's on the bottom. Here we've got a 3, we got an 8, and what's here on the bottom? Yeah, it's a 1. So our LCD for this problem is going to be 24. The LCD is 24. That means we want to multiply both sides of that main equation by 24. So I'm going to recopy it so it's pretty. X minus 2 over 3 equals x plus 3 over 8. And I'm going to multiply both sides by my LCD of 24. And of course our next step is going to be to distribute that 24 across. I'm apparently not going to get anything done. Oh my. So, if you think that you've got it tough trying to study at home, I've got it tough too. Oh my. So then we're going to add, I clarified my problem, I'm going to distribute that 24 over, and get x minus 2 over 3, times x minus 2 over 3. And then that 24, I'm just reversing the order. I'm not doing anything weird here. I'm just changing the order. And the only reason I'm doing that is because I want you to be able to see that we had 3 terms, 1, 2, 3, originally in our equation. And we still have 1, 2, 3 terms, and each one of them is multiplied by 24. Okay? And I just want you to be able to see that. So we can simplify a lot here, actually. We've got this 24 over 3. Remember, the whole point is we're trying to get rid of these dumb old fractions. So 24 over 3 gives me 8. 24 over 8 gives me 3. So now remember, I don't want to skip this next step. I want to write everything out. So I've got 24 times 5 is 120 plus, now I'm going to write 8 times x minus 2. Do not go ahead and distribute that already. Just go ahead and write it out so that you're sure you got it right. 3 times x plus 3. Alright, so the next step is to distribute appropriately. And we've got 120 plus 8x minus 16 equals, the 3 distributes to get 3x plus 9. Alright, now again, we're going to combine like terms. We're reading The Very Hungry Caterpillar, it's fun. 120 minus 16 is 104. You're right, my 8x first. I like to keep them in order. 8x plus 104 was 3x plus 9. And then I want to move x's and numbers to each side. Okay, so I want to move my 104 over, so I'll subtract on both sides, leaving me with 8x equals 3x plus, minus 95. Alright, now I want to get all my x's to the other side, so I'll subtract 3x on both sides, and that gets me 5x equals negative 95. Now I can divide, because I moved everything around, so now I can divide. Remember, we don't want to divide until we got all our x's on one side and everything else on the other. So what can I divide by? Divide by 5. So I've got x equals 95 divided by 5. Yep. Alright, is negative 19. So I got my answer there. And again, the whole point was I took this really, really awful, nasty, disgusting thingy going on here, this, whatever you call it, equation with fractions in it, rational equation, and I simplified it out to something very pretty right here. So this is why you really don't want to skip this stuff. This is the whole reason you're doing this, is to get rid of the fractions. So you really want to make sure you write that stuff down. Simplify, and then we've got an answer. This is a crazy day. Puppies are going nuts. Alright, so I'm going to write the next one, and hopefully you'll pause and try to work it out independently and see where you get with it. X minus 3 over 4 equals 5 over 14 minus x plus 5 over 7. Okay, so if you get a chance, pause it and work on it. If not, or if you already did, here we are back and working this out. So remember, the first step is to find the LCD. Look at the bottom numbers on each one. Well, what's my LCD? It's 28. 28. So if you got something bigger, that's fine. If you got something smaller, it's not the end of the world, but you're not going to get rid of all your fractions. The idea is that if we take these 28 and I multiply it by the first one, that'll get rid of the 4, right, because I'll have a 7. I'll get rid of the 14 here because it'll leave me a 2 on top. And it'll get rid of the 7 here and leave me a 4 on top. Okay, so again, the idea is we're multiplying this LCD out specifically so we can get rid of all the fractions. So let me write this out again. And I'm going to multiply both sides by the LCD. Wait, not LCD, the word, but by 28. I'm going to distribute that 28 across. And I'll get 28 times x minus 3 over 4 equals 28 times 5 over 14 minus 28 times x plus 5 over 7. Now I'm putting the 28 in the front because that actually makes it a lot easier. To put it in the front, for the purposes of whenever you are distributing this negative through, it's just gonna look weird if the 28's on the other side. So I'm putting the 28 first because it kind of just matches the pattern that I've been doing. Got my 3 terms, term, and then I got my LCD. So that's not 28. There we go. So that just nice to have a pattern. So I always know what I'm doing. If I always solve it the exact same way, I can't get too confused, you know? So I've got 28 over 4. It's going to come out to 7, which is good. Got 28 over 14, which comes out to 2. 28 over 7, which comes out to 4. So I've got 7 times x minus 3 equals 2 times 5 minus 4 times x plus 5. Remember, this is a step we don't want to skip. Always go ahead and write it out, even though you might think, oh, well, I can do this, I know how to distribute, blah, 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 blah. Don't do it. It's not going to work. And if it does work, it's probably because you got lucky, and that's nothing against anyone. It's just that I would mess this up. So the reason I write it out is because I need it to make sense. So go ahead and write it out so that you're sure of what's going on. All right, so now we want to go ahead and distribute that 7 through. We're going to distribute this negative 4 through. So 7 times x, 7x, minus 21 equals 10. Minus 4x, minus 20, minus 4 times plus 5, negative 20. All right, I'm all simplified over here for the moment. Negative 4x plus 10 minus 20 is minus 10. Now remember, I want to move x's and numbers to each side. So I like to have my x's on the left, so I'm going to move my x's over here. I'm only going to move one at a time, so I make sure I don't do anything silly. I'm going to move my numbers back over, so I'll add 21 to both sides. And that lines me up with 11x equals, so I don't know, 11? Alright. Now that I've got all my numbers on one side and all my x's on the other side, now I can divide. So I'll divide those sides by 11 and get x equals 1. Now I've got a super fancy, fantastic answer that I'm inordinately happy with. Alright. So this is everything we're doing with the fractions with only numbers on the bottom. So again, the point was we took something that was really ugly with fractions, multiplied the whole thing by an LCD, and what ended up happening was by the time we got to this step right here, we had no more fractions left, which made us super happy. Combine like terms, get everything on one side, all the x's on one side, numbers on the other, divide out, and then pretty quickly you get your solution. All right, so get really used to this process. If this is really strange to you, go back to the original problems and rework them out. Make sure that they make sense to you. And then basically just make sure that you're really confident with what's going on here before you go on to the next section, because in the next section, instead of just having numbers on the bottom, we're going to have numbers and variables and other kinds of expressions. So you really want to be confident here before you move on.